Righto, welcome all to the Genetics of Foot Health in Merinos webinar. My name's Mark Ferguson, joined tonight by Amy Lockwood and Gus Rose. Amy works for us at neXtgen over in WA, and Gus Rose at UNE/AGBU. I'm going to hand over to Amy in 2 seconds, but just quickly wanted to sincerely thank a range of people that have made this project possible. It's in collaboration with Murdoch University. It's funded by Animal Health Australia and AWI, and part of that Animal Health Australia is support from Wool Producers Australia and Sheep Producers Australia, which we very much appreciate. And obviously a whole range of stud breeders that are dedicating their time, effort and cash to help us do this work. So we're about to see lots of data that's being collected across a range of things. And so, very much appreciate their support. And also just wanted to very much appreciate and acknowledge Todd Berger, who runs the site, or owns the site where we run the work in Victoria, and Georgia Buckles, who does that work as well, and the entire team on the project. But obviously, when you ask, put your hand up if you want to run a foot rot site. There's not too many people put their hand up, so fantastic to have Todd to do that. But I'll hand over to Amy, who will then hand over to Gus to run through the results we've got to for so far. In your somewhere there'll be there's a chat, and there's 2 different boxes. One's a live Q&A, so you can ask. There's a little question mark down the bottom of your screen. There's also a chat, so you can chat to individuals that might be on this call. But if you want to question anything, just drop it in that live Q&A, and we'll try and answer them as we go. All right, thanks, Amy. We'll hand over to you.
Thanks, Ferg. Again, just a huge acknowledgement to AGBU and Animal Health Australia, along with the collaborating merino breeders that are involved, for funding this project, which is conducted by neXtgen, Agri and Murdoch University in collaboration with AGBU. So just a bit of background for the project. So MLA's endemic disease report showed that foot diseases are estimated to cost the Australian sheep industry over $90 million per year. And that's through a range of disease and structural issues which result in lameness and pain, leading to loss in weight or conditions for the animals, poorer wool production and poorer reproduction. So foot health issues are a big issue, particularly in wet years and high rainfall zones. So in New Zealand, some research over there has led to the development of a foot rot breeding value, which has been demonstrated to reliably reduce the susceptibility of sheep to foot rot. And some recent work in Australia, funded by Animal Health Australia, has shown that similar genetic variation exists within the Australian merino population. I guess the difference between Australia and New Zealand is that in Australia we can't trade, or stud breeders can't trade rams that have, when they've got foot rot on their property, and so we actually need a designated research site where we can challenge different merino genotypes to foot rot to be able to investigate the differences in disease susceptibility. So the overall objectives of this project are to look at the genetics around foot disease and foot structure, so generating heritability estimates for the foot structural traits, foot abscess, ovo and interdigital dermatitis, which is commonly known as scald, and foot rot, to estimate the phenotypic and genetic correlations between those foot disease and structural traits. So I guess the previous work, what we don't know is, are there any indicator traits for foot rot and other foot diseases? So, for example, if sheep are prone to having long toes, does that predispose foot rot, and can we use that as an indicator trait? The project will generate within flock and preliminary breeding values for these foot traits, and an ASBV eventually for foot rot will be generated for the Australian merino industry. I guess the overall objective of the project is to identify and inform the industry on appropriate selection strategies that can improve foot health and therefore animal welfare and productivity. So there's 3 components to this project. We have the central progeny test. So this year was the second year of that progeny test. The Cull Ram Challenge and the collaborating breeder site. So we'll touch on each of these 3 components briefly. I guess this is just an overall snapshot of the project. So we've got the central progeny test where we're evaluating progeny from a range of different Australian Merino sires, collecting production data, structural data on the foot structure, and OID and foot rot. The Cull Ram Challenge will also be getting cull rams where we're collecting that structural and disease data, and we've got their pedigree information. And then our collaborating breeder sites where they're collecting their own performance data, and those structural traits and foot abscess and scald are also measured. So that's a huge three components feeding in a huge amount of data for both structure and disease, with the ultimate goal of generating breeding values for those traits. So the Central Progeny Test has involved 2 AI programs to date. So we have one in 2024 and one this year. And these are the sires which have been used in the program so far. The ones that are highlighted in yellow are our link sires. So we had 26 sires used in the first AI program in 2024, and then 16 sires involved this year. So from the 2024 drop, we weaned just over 700 lambs, and they were their data collection was completed a couple of months ago. So we've collected a range of production traits, scored all of those progeny for foot structure. We captured foot rot in the wethers. Unfortunately, they skipped scald and went straight to foot rot. And we got scald in the ewe progeny, and they didn't proceed into foot rot. So we've ended up with about 300 progeny measured for foot rot and scald in that first drop of progeny. The 2025 drop have just been weaned, so we weaned just over 430 lambs from 16 sires this year. They've had their weaning weights collected end of last week, and breech wrinkle and cover collected at marking time. So the range of other production measures, as well as that foot structural and disease data, will obviously come in the next 6 to 12 months. So just in terms of this, the structural data that's been collected, there's a range of traits that we're assessing. So foot shape, which is essentially measuring the length of the toenail on a score of 1 to 5, 1 being the normal toe, and 5 being very long and overgrown. Foot roll, so whether those toenails are rolling outwards or just rolling, again on a score of 1 to 5. Front foot twist, which is essentially reflective of hocks in the hind legs, so looking at whether those feet are turned out, and then front and back pasterns as well. So there's a range of structural traits that we're looking at, and they're scored, all scored on a 1 to 5 scale. So a lot of numbers here. We won't go into too much detail because this data will be discussed in Gus's presentation, but this is the foot structural data that we've collected from the 2024 drop out of the CBT. And you can see there, based on the averages, we've tended to have progeny with slightly overgrown toes, so score 1 being the perfect foot. So we're getting some overgrown toes, fairly normal pasterns, and hocks and front twists. So it's mainly a bit of roll and overgrown toes that we're seeing in those progeny. So these are the foot rot and scald scores. Again, we won't go into too much detail with these because they will be covered in Gus's genetic analysis. But good to see plenty of variation there in those 2 traits amongst the 24 drop progeny. So that's the central progeny test. The second component of the project is the Cull Ram Challenge. This hasn't gone ahead over the last couple of years, largely due to dry seasonal conditions, but also a little bit of lack of interest. We are planning to conduct the Cull Ram Challenge next year and potentially in 2027. The aim of this component is for teams of at least 8 cull rams to be nominated from different breeders, with the goal of measuring 100 sires over the course of the project. So they're assessed for scald, foot rot, and foot structure. And the third component of the project is the collaborating breeder sites. We've currently got 21 breeders on board across Australia, which is really great, and measuring their progeny from the 23 drop onwards. So we've now basically measured the 23 and 24 drop, and next year we'll start measuring the 25 drop progeny. So over the last couple of years, we've measured nearly 39,000 progeny from the 23 and 24 drop for foot structure. We haven't seen any foot abscess or scald in those progeny to date, but basically from 100 days of age, the current drop of progeny is monitored for those diseases, and if they reach the threshold for scoring, then we're able to collect that data, and that will feed into our database. I think I missed a slide here. I'll hand over to Gus now, and then we'll jump back and go through the options for breeders to get on board with the project.
Thanks, Amy. I'll just share my screen. So I'm going to present a bit of the preliminary genetic analysis. And I guess the big word is preliminary because, like Amy said, we've still got lots of data coming in and to come in. But we are getting enough data to get a bit of an idea of what the traits are looking like and how they're correlated together, particularly the foot structure traits, which have been measured on other animals apart from those in this project. So we've been able to collate quite a bit of data and look at them. So what we want to know, Amy touched on it, is to look at foot structure traits. Any of those are a good indicator of foot health. And we also want to look at foot rot in Australia. We've got a breeding value for New Zealand, and the long-term goal is to have a foot rot ASBV for Australian breeders. And we also want to look at ORD to see how that was correlated with foot rot and, of course, the other traits as well. So the analysis that I did was essentially what it does is it tries to work out why sheep look like they do. And we try and split out the things that we know about the animal, like their age, how they were managed, if they were managed as a twin or a single, with the genetics, because we know the relationships between the animals measured. We can disentangle this to work out a breeding value, and how much of the variance of what animals look like is because of genetics, essentially. So this is a genetic analysis of all these traits, and then looking at the correlation between traits. So we do have lots of records, particularly for the foot structure traits, because we have a lot of those coming in. I'll talk about it a bit more in detail later, but some traits were a lot nicer than others in the way that there was more variation in some traits than others. So I had to remove quite a bit of hocks behind at this stage because there weren't that many contemporary groups or groups of animals that were measured together that had a lot of variation. And from this project, it's like Amy said, we've got some foot rot and ORD, but we don't have a lot yet, and we'll certainly get more coming in. So I'll present a bit of a preliminary analysis, but also realize that we don't have a lot of records individually from the project, but we're doing our best with what we can do with other information as well. So in summary, these are the mean and standard deviation of the foot structure traits. And you can see that some of them had a higher mean on a scale of 1 to 5 than others. But also, more importantly, you can see that some traits had a higher standard deviation, which means that there was a lot of good variation. whereas other traits had poorer variation. And I'll talk about it a bit more, but when I was putting this together, and if I was looking for the hero of this story, it's definitely the foot shape. And if I'm looking for the villain, it was the pastern, particularly in terms of the data, and then trying to analyze it and get and interpret the results. And part of the reason for that is that a lot of the pastern information coming in were only for one score, whereas foot shape had a lot better distribution of the of collected data across the 5 scores. And if you imagine that you've got all of one score, there's not much variation, and it's really hard to work out which size progeny were better if a lot of the progeny have the same score. So in that way, the foot shape is definitely the hero because it was a lot easier to analyze also for me, but then the pastern makes it a little bit harder to analyze. And this is kind of a theme that you can see throughout, particularly when we start looking at the heritability and the correlation with other traits. So to get the heritability, we want to look at that variance. And I showed you before that some traits have better kind of variance than others. And we want to work out the heritability. So essentially that's how much of this variance or how much animals differ between each other is explained because of genetic differences based on relatives' performance versus other things that we can't measure. And so obviously if we get a heritability ranges between 0 and 1, and the higher the heritability, the easier it is to change that trait through breeding. And then again, we get our heroes and our villains. We've got the foot shape, which has good heritability, is easy to change. So if that was going to be an indicator trait for foot rot, it's something that you want because you can easily change it. But then if we look at our front pastern, for example, again, we'd say that's a bit of a villain at this stage because it doesn't have a good heritability. We can't explain a lot of that variation, and there's little variation, so it's also harder to change than our foot shape. So at this stage, given the data we have, then I would say that the take-home message is that foot shape is the easiest to breed for with the data we have at the moment. Other traits have a more modest heritability, and we need to put a bit more work into this analysis of these poorly distributed traits. And there are things we can do, which we can look into for future analysis, because this is quite preliminary at this point. And then we can look at the genetic correlations between traits. So essentially, it's how much traits will change together. So a higher correlation between 2 traits means it's harder to change both independently, which can be a good thing and can be a bad thing. So in the case of if we're looking for an indicator trait for foot rot, you'd want a high positive correlation between foot structure with low being better and foot rot with low being better as well. So I'll present a bit of that at the end, but first of all, I'll present the genetic correlations between these foot structure traits. And I think this is kind of like an ugly table because it's got a bit of everything, a bit of a mixed bag. But I think that the key things to look at, you've got, for example, here, back pastern and front pastern. And we want to know if you have a poor back pastern, you'll have also a poor front pastern in general. If you're selecting, then we've got this genetic correlation, which is suggesting that the front and back are similar traits. So 0.45 is okay, but for example, foot shape is the back and the foot has got a correlation of 0.77, which is a lot more favorable. So you can have a lot more certainty if you're selecting for foot shape that if you just measured the front, then you wouldn't have to worry about the back. And then we have all of these other kind of mixed correlations ranging from low negative to moderate to high between all the traits. And I think a lot of that is because some of these traits are a little bit difficult at this stage to analyze. But if you look at, say, the foot shape, which is a bit easier, we can see that things like back foot roll is also correlated with front foot shape, for example, which could be important. But essentially, this is just kind of looking at the correlation between the structure traits. If we were going to have several indicator traits that you might use for foot rot and OID, then these correlations obviously become important because they can help provide more information for other traits. But the main event, which I'm keeping for later, is really the correlation between these traits and, say, foot rot and OID. So the take-home message is that front and back seem quite well correlated for some of the traits at least, which is a good sign. And we have a bit of a mixed bag in terms of the correlation between other traits, which may or may not be important when we include in these traits and foot rot, say, in a genetic evaluation. So finally, we get on to foot rot in Australia, where we're obviously collecting data from this project. We also have information from the MLP project and from Australian breeders who have been submitting data for foot rot themselves. So we are starting to accumulate a bit of data which we can use to look at foot rot in Australia. And so to analyze this, I use the same protocol that has been used in the New Zealand work, where you need to make sure that the foot rot challenge is real. So at least 10% have a score 3 foot rot, and at least 50% have a score 2 or above. And if we look at the heritability of foot rot in New Zealand versus Australia, we're looking at quite similar heritability, which is good. And even OID has very similar heritability. But New Zealand foot rot, we've got, I don't think I put it in there, we've got like more than 20,000 records. So I think it's even 40,000. So we're pretty certain about that heritability, but we still need to get more data, obviously, for Australia and for OID, because we didn't have that many only from this project, to get more certainty in this heritability. And also this also translate into the correlations between traits. So the take-home message is that the heritability is quite consistent at this stage, but we don't have a lot of certainty about OID for now. But as we get more data in, we can look at that. So this is very much a preliminary estimate for that. So this is it's quite an interesting table, because it's showing what the genetic correlations are between our foot structure traits, which we have lots of, with OID and foot rot measured in Australia. And the thing about this data is that we don't have a lot of the foot rot data measured in Australia, which also have the foot structure traits and also OID. So there is a lot of error in this, but still there are some positive things. When we talk about our heroes and our villains, it looks like foot shape has positive correlations with foot rot, which is, like we said before, is favorable, because if we improve foot shape, we can decrease foot rot through breeding. And that 0.77 is great looking, but again, it's got a lot higher error, and we still need to do a bit of work. And then we've got our villain, which was Paston again, which is doing weird things like saying that better Paston will decrease foot rot, which when you get a bit of faith in the foot shape, then those kind of correlations come up. But I think it is really due to this lack of variation and the traits being very difficult to analyze at this point. Because you can also see there are a lot of gaps there where we couldn't get certainty around the correlation, because we're having difficult analyzing with some of those other traits. So we really do need to get more information in to get more certainty around those. But I guess the take-home message is, or the first one is, we need more animals with both traits measured. But we do have some interesting and favorable correlations, which would be good. There may be some unfavorable. But then when you think back to the earlier tables where we're talking about heritability, the trait that you could change easiest was foot shape. So that's the one you want to have a good association with, or not association, correlation with foot rot as an indicator trait anyway. So it may not matter, some of those unfavorable correlations. But we still have quite a bit to go in terms of getting more data to make sure that these correlations are quite certain. And I put these in even though they have quite a high error, was the OID and foot rot had a positive correlation, which I think is a favorable thing. So it means you can almost select for both of those together. Although it's still quite low, that correlation, we don't have a lot of data, obviously, and we don't really have much data on the same animals, which, like Amy said, pointed out before, would be good to get. And then I did an analysis of foot rot in Australia and New Zealand. And again, the correlations really depend on having animals measured in both environments. So there's a bit of history to this because we've got foot rot measured in New Zealand, and we want to make sure that foot rot in New Zealand is essentially the same trait as foot rot in Australia. What we need is probably more data, and I haven't done this with genomic relationships between animals. So obviously when you rely on the pedigree, it just depends on what size have been used in common across both countries. But with genomics, you get genomic relationships between all animals, which can help with that correlation. So that's something we definitely want to look at in the future as well. But up to now, the correlation is positive. It's high-ish. I didn't put it in there yet because we're not that confident about it, but it certainly looks positive in terms of the right direction and being something that we can select for together. So I'll talk a bit more about how that might be implemented later. We've got a range of breeding values for the size used in a project for the different traits. So the take-home message here is you've got quite a bit of variation in breeding values, which means that we could start looking at size or even animals to select for at this earlier stage. And the take home there is that we do have preliminary breeding values available for participants. And again, there's variation in the size for those breeding values at this stage, which is something which we can start utilizing early on to get an idea of which ones to be good to go. So the future work in the short term for this project, obviously as more data comes in, we can start checking some of those correlations a bit more. In the longer term, the plan is to have a foot rot trait for Australia. And obviously that depends on a bit on this work and the correlations between those traits. So ideally to be really highly correlated and we wouldn't have to have two traits. But if we do, that's something which we'll look at implementing in the future. And another thing which has come up a little bit also with New Zealand breeders that Mark wants to talk about it more is the threshold and the trait definition, because obviously you need to have a challenge of foot rot to collect foot rot records. So something we would like to do is also look at whether those thresholds can be changed or if we can have a different trait defined with a lower threshold, which can also still provide information for the full foot rot, but that's something which we can also explore as we get more data. So the conclusions that this is obviously the first preliminary analysis, so there's a big chunk of salt to be taken with it. But as we get more data and a more robust analysis, we can start looking at it more. But I think early on, foot shape looks really promising. And also the correlations between other traits, even though we don't have a lot of data, looks quite promising. And if I was a betting man, which I'm not, I would probably put my money on foot shape as being the winner, but we'll just have to see how we go, particularly in looking at some of those other traits and analysing them in a bit more detail. I think that's where I'm up to, Mark. That's all I got.
Thanks, Gus. Yeah, really interesting and pretty exciting for us as a team, having sort of chipped away for a couple of years probably, and now that's literally these are pretty fresh out of the computer, obviously. So trying to get my head around correlations as we go, and yeah, there's where we need more information. So yeah, it is nice to see foot shape behaving well. I guess the key point for tonight is that if you're a Merino breeder or you know a Merino breeder, and we've got an opportunity now to get another entry into or another set of size into the progeny test, so we get more information. We can still add breeders to to the collaborating breeder sites to get that foot shape information. The range we saw in those breeding values, which I'm just getting my head around, but it looks like at least over a score range in the breeding values of the size we've scored so far. So, and that can be the difference between a ram that sells or has gone into the cow pen, and I guess getting around a fair few sire selection days and sale ram selection days. One of the biggest wastage factors in merino sheep is that foot shape type stuff, or just sheep that are culled because of their foot shape. So, and if it is favourably correlated with OID and foot rot, then we kind of win on all fronts. So I guess, yeah, for merino breeders out there, this is a big opportunity to get involved before this project finishes up. And yeah, we don't know what that looks like in the future, but it's a great opportunity to have your data in the foundation of this information. I think it's going to be it's going to be really significant for the industry. It's without without the obvious pun, but feet have been the Achilles heel of merino going into those higher rainfall environments, and a lot of work involved. A couple of questions that have come through. Kate has asked about foot fibroma. Have we scored it and collect data? And the answer is no. My understanding of fibroma is that you need chronic challenges, so it's on places where you've had disease around a lot. What we've been doing in this project, and same in New Zealand, is getting short, sharp challenges. So they're allowed to get foot rot through a challenge and then cleaned up as quick as possible. Obviously, if you clean it up perfectly, that'd be great. But yeah, not animals that are being exposed to lots of for a long time, I suppose. And but typically you might see that when you go out to a farm where it has got chronic foot rot or whatever, you'll see those sort of things. But no, we haven't had that level of challenge or that sort of data coming in, and probably won't get it. Question from Elise Keeley around, which were actually emailed through because she knew she couldn't be here. I should just get them up. But the one question was around the causes of scald. So Gus has been talking about OID, which some people refer to as scald, ovine interdigital dermatitis, or clover scald, as often it's referred to. But essentially, scald or OID is where you haven't got any underrun into the hard material. It's just that infection between the toes. And so Elise's question is scald caused by the same bacteria as foot rot, which is Diclobacter nodosus? And the answer to that is, well, it can be, but mostly, so nodosus can contribute to that, but the main cause of that is fusiform, which is, what's its real name? Fusobacterium negriforum or something, but fusiform as I refer to it. But so it's a different bacteria that's present on all farms. So it's just in fecal and mud, and so when things are wet, warm, and there's feces around, you'll have that on. So it's just sort of there in all soils, and that can cause. Well, that is what causes OID. So it's sort of a conditional thing normally, but then obviously Diclobacter nodosus needs to be present to cause underrunning foot rot. The different virulences of that strain will impact how much of sort of how good they are at releasing those extracellular proteases, nodosus can release basically a protease that chews through that keratin material and causes the damage, but that's the only bacteria that can do that. So fusiform can't cause underrunning. It's unique to nodosus, and so if you've got any underrunning, then you've got some version of foot rot, whether it's a benign strain or a virulent strain. Will just depend on how much of that protease they release, and therefore how much damage they can do. Sarah's asked about the correlation between foot shape, cause or effect, and that's a good question, and something we haven't. If anyone online feels like doing a PhD in foot rot, I think that'd be a great area to do, or foot disease in general. So, I mean, you can cause. I think, from what I've seen, I think it's effect. Not. I think you need some irritation there to. Well, here's a theory, and we haven't got any evidence to back this up really. But a potential theory is that you get kind of. If you get an infection, you get increased blood flow to that area, which then just by osmosis almost, you get greater protein growth or greater growth of that foot material pushing out that length. So that's a link that I can develop in my head. But then we're seeing these correlations, and some of those sheep might be in dry areas. So there's a fair bit of work to do yet to really understand. We haven't got the level of data we would need to start to pull these things apart. So there's lots of that sort of stuff that we need to understand cause and effect. Whether, I guess, if the correlation is consistent across environments, it kind of doesn't matter whether it's cause or effect, because we can use it either way. We either can select for foot shape. Obviously, in Australia, it's going to be really hard to select for foot rot, because it's a notifiable disease. But these correlations we can use to, so if OID and foot shape are both favourably or positively correlated with foot rot, we can make gains on foot rot resistance by selecting them. And that's definitely what we've seen kind of over time. Animals that throw good foot shape a range of environments are also tend to be those that throw foot rot resistant progeny as well. There's certainly outliers in that. We've seen, so there's a lot of understanding to do to go yet, and I think in these biological things you don't always or may not ever fully understand what's going on, but we can certainly, our aim is obviously to help the industry make gain, and I think this has been a really great step forward for the Australian industry to make gain across these foot traits, and we've seen certainly in this process of uncovered sires that are really quite unique in their ability to throw good feet, good progeny with good feet, and that's what we need more of. Miranda's asked how many years of measurement will be undertaken for the evaluation, and do scores change much between years? So this was originally a 3-year project. It might stretch a little bit, but it's 3 to 4 years. But I guess there's been ongoing work pre and will be post this project in terms of breeders that were doing a lot of this foot scoring. We've got a lot of data that was collected before this project. There's a lot of information being collected in New Zealand. So if we can draw those links between countries, it'll be kind of an ongoing forever type thing once we work out which of these traits should get turned into breeding values. As Gus has already shown, it looks, if you're going to pick a couple to turn into breeding values, it'd be something around foot shape, and that as a way to select for, well, foot shape itself is obviously important, but also if it brings us resistance to OID and foot rot, all the better. Kate's comment is that most OID or scald lesions in South Australia is foot rot from the laboratory analysis, and I think that's probably quite true. I think there's lots of benign strains or less virulent strains of foot rot that at least contributing to what is thought to be scald or thought to be OID, and I guess there's lots of that going on out there. The more we've seen a lot of feet through this project, and then a lot of different areas, and turned a lot of sheep over. Not me anywhere near as much as my team, but I think there's lots of some version of foot rot out there across the industry, particularly high rainfall areas, obviously. But I think that sort of highlights the importance of this work. If we can build sheep that are resistant to these diseases, then that prevalence disappears or reduces a lot. You see it obviously more in final sheep than some other breeds. So there's big, I think the prevalence of it out there is an opportunity for really, and I think you may have heard me tell this yarn before, but if we think about what's happening in New Zealand, and there's lots of places that are now having a lot less requirement to put sheep through zinc and stuff, just through selecting for these breeding values, the foot rot breeding value that's been available, but also foot shape. I think, and it is going to be a lasting impact on the industry and a lasting shift to sheep with less problems around feet health, which we all know how awesome that would be, to run sheep onto great pastures, not having to worry about whether their feet are going to be okay or not. And so that's kind of the aim of the work, and certainly what we're seeing, being 13 or 14 years more advanced in New Zealand or probably 10 years, I suppose, really, from the start of this project. But and seeing what that's playing out like in the industry. What the other cool thing is, I think, is that I don't reckon we need to shift these traits too far before it starts having an impact. So um, you take out the kind of the normal. If you think about the normal distribution of feed health, and you've got the ones that are really bad out on the left hand side or right hand side, whichever way you want to look at it. If you drop that half of the population out, then what's left is much causes you a lot less grief. So I think a lot of the grief that we're having on farm with feed are only a portion of the population, and so this project and the breeding values that will hopefully result from it will kind of give us the tools to find those ones that are susceptible and weed them out of the population. And I think that's going to have the lasting impact. Sarah's just asked about the variability in paston length or paston angle we were measuring, and yeah, whether it's something that has already been under selection. I think that's probably possible. It's interesting, like having done a fair bit of this scoring. I'm sort of left wondering whether our two has been too like we've literally only just seen these analyses and we've been charging on getting these scores done for a couple of years, and so I'm wondering whether we should have divvied up our two a bit, like whether we got our angles right, and it is a pretty hard measure to score in a moving animal. Obviously, often this is done in a classing crate or whatever, which is they are, particularly back pastons, are quite hard to look at when they're pushing back on the gate. So there's a couple of errors or a couple of sources of error in that. I also think, and happy to be shouted down, but what we see anecdotally at least is that animals that grow fast or get heavy early in their life tend to be the ones that have paston problems. So is that kind of, I think what we are hoping to work out over time is how much of that is genetic and how much is just some environmental sort of damage that had they grown more slowly that wouldn't have happened or whatever, or does that just highlight the ones that get it? That's so a low heritability means that we're not accounting for much of the variation through the known part of their genetics. So it could mean that where there's a scoring error, or it could mean that there's a massive environmental impact, which potentially is on the cards, because I do think we should see a bit of variation, and obviously the data doesn't reflect that, but it feels like we see a bit of variation. But there has definitely been a fair bit of, like, it's something that anyone looking at a sheep can see a poor paston, so maybe they have been weeded out of the environment, but I think that's probably not highly likely, considering there's lots of other traits that you would think would have been weeded out that haven't been. But an interesting observation. Yep. I guess it's worth. Yeah, I guess Gus has already pointed out, but one of the points of this project was to that trans-Tasman correlation, and again, it's going to take time to build that. But if we don't start, you don't get it. But that's really what we want, is an ASPV that works in both Australia and New Zealand for those that can collect the data. Perfect world, we see a nice correlation between OID and foot rot, which hasn't shown up yet. But again, very small data set. One of the probably challenges, and to Kate's point, I think it's trying to get OID without going to foot rot where nodosis is around is really hard, particularly virulent strains of nodosis. In New Zealand, we never really knew whether, like, it was all just because there's lots of virulent foot rot around, or in the places we were playing, we never really got to separate what was OID and what was foot rot, and they are so interchangeable, I guess. And maybe it becomes over time, I guess, if you think about on the foot rot score, a score 2 can be anything from like a really little bit of irritation through to a very inflamed interdigital space, but no underrunning. And so I think anyway, I mean, part of the things that we'll evaluate is whether we can divvy up that score 2 a bit, and give us some more, so whether that becomes a 10-point scale or whatever it looks like. But anyway, these are the things that you do projects for, to try and understand that. so that because they are like a sheep that's just got a little bit of inflammation there is running around fine. One with a very inflamed interdigital space could be quite lame, and so their health and welfare impacts of those scores are quite different, and that's why anyway we need to really pull that apart, and that's what we'll do going forward. Another question that Elise asked, and I'll get to Chad's question next, is around the current breeding value. We sort of penalise the score 4 worse than having a 1 or a 2, because 1 or a 2 you can get a 1 or a 2 without nodosus being present, and certainly the underrunning is kind of what is classically known as foot rot. So yeah, the question really is a sheep with 1 0, 2 2s and another 0 better or worse than one with 3 zeros and a score 4? And I guess through the original work we did in New Zealand, we made the call that an animal with a single score 4 is worse than an animal with 2 score 2s, because the 2 score 2s can, like, you run that through zinc and that can be healed or can be cleaned up. It may not be, but it's more likely to. A score 4, you've got full underrunning across to the other wall of the claw, and so the chance of having a little pocket that the zinc doesn't get to and then that doesn't get healed is much higher. And so and that, I think through the work we've done there, to get to score 4 means you're way more susceptible. I don't know what's going on in the immunity of the animal, and whether that's fighting the proteases that the bacteria is releasing, or the bacteria itself, or what's going on. And I guess that would help us understand but anyway, so far, I think if we just stick to the evidence, which is that the breeding value is based on 1s and 2s being less a problem than 3s and 4s, and so they're just weighted slightly different rather than pure in a linear fashion. It seems to be working and pulling out those animals that are more resistant. So we'll keep running with it until we get better information. Chad's asked how far are we from being able to source genetics from New Zealand, and that's a question for any government officials on tonight. But so that the product, or the border's closed because of scrapie, which is some sheep were brought out of Europe into New Zealand that didn't follow the scrapie, or lots of sheep have been brought out that haven't followed the Australian protocol for scrapie, which mean under that protocol you've got to get old animals and then kill them and do a brain check the brains out before you import the genetic material. So New Zealand didn't follow that protocol and haven't got scrapie, but it would need just a bit of political will for someone in Australia to fight someone in the government, or to encourage that border to change. And I guess, I don't know, I mean, my summary or assumption is that that trade is somewhere down the priority list for Australia, and so I'm sure AQUIS have got a million things to do, and that must sit down the bottom of the list somewhere. It could be, I think through political will, it could be brought up the list, and I think there's plenty of evidence to say that we can import from New Zealand to Australia without any scrapie risk. But I guess it's the problem with scrapie is it's quite hard to detect, and it can sort of show up after being in a seemingly sort of healthy animal later in life. So it's a bit of a tricky disease. I don't understand it that well, but enough to know that it's got Australia concerned, I suppose. And I think it's fair to say we're better off putting up with foot rot in Australia than we are having to introduce scrapie accidentally. So it's good that governments are cautious, but I think that border could now come down. And based on the fact that those animals have now been in New Zealand since 2017 was when it closed. So there's sort of 8 years of those animals being around. If scrapie was going to turn up, it'll be here. So I think, with the right effort, it could be fixed. But anyway, and I guess why would we want to do that? We'd want to do that because there are sheep here that are very resistant to foot rot because of the 13 years of work, and because it's got lots of things about it, New Zealand, but one of them is good at breeding foot rot. So, and so there's perfect conditions here quite a bit of the time, and no restrictions on trade for having foot rot. So stud sheep can be challenged and go on to be stud rams, and without any any implications, which means that we're making much quicker genetic gain here than we will in Australia, just by, unless we can find some of these either genomic relationships or these correlated traits, which is all going to, I think that in the ecosystem it'll all work because there'll be genomic. Kiwis are still importing sheep from Australia, and some of that genomic relationships and pedigree relationships can be used to get it all link it up. So I think there's all is not lost, and maybe it is that we'll end up having progeny tests in New Zealand rather than Australia, just if we can continue, if we need that to continue to build the data. But that's something that we'll get to down the track. But I think it would be nice just to grab some genetics out of here that have already gone through the hard yards and make some gains. But I think we've already shown in this work so far is that we've found rams that may not be as good as the best in New Zealand, but certainly further down that histogram than others. So we've certainly, I can just encourage just as many breeders as possible get rams in and into the progeny test while the opportunity exists, because this is going to be our opportunity to find the freaks, and if they're not in it, we can't find them. And particularly that ram challenge site, which really hasn't been used. But the problem with obviously setting a sire into the CBT is you get one sire in there, whereas if you send in cull rams from, or cull progeny from your sires, and there's at least 8 animals per sire, they can all get challenged, and so you can all of a sudden have 10 or 12 or 15 of your sires that are getting foot rot breeding value or foot rot data that hopefully gets turned into a breeding value, versus that one sire that's been really comprehensively evaluated. So all very important. We've done. We started here in New Zealand with about 300 sires progeny tested for foot rot, and then went to breeders. And it's now sort of fairly routine in the system. Still not something anyone loves doing, obviously, and still a challenge. But I guess the upside is massive. Any other questions out there? You've got on your screen the QR codes to get to more information if you are a ram breeder. All that we require is that you're submitting your data to Sheep Genetics, so that we get all the other relevant data on those animals, and that it can contribute to the wider thing. I don't know, Gus, if you want to talk about kind of genomics, and that's a question without any notice, but ideally this trait becomes genomically or can be predicted through single step. Currently, it's, as far as I'm aware, it's not, but I guess one of our significant challenges there is probably the Kiwis haven't done a lot of genotyping of animals. So we've got lots of phenotypes in New Zealand, but very few genotypes that match them. We've got lots of genotypes in Australia, but not many foot rot phenotypes. So we're kind of left with a small crossover population, which is a bit of a challenge.
Yeah, I think that's a good summary of where we're at. Obviously, we get to build a reference. We want both moving forward, but it's a lot easier to genotype than to collect a foot rot record, it seems, especially in Australia. So it's going to be definitely a challenge, even past this project, I guess, to maintain that reference population, which is why looking for other traits is also an important thing to do, and also to genotype across countries too, to get those relationships a bit better, like you say. Yeah.
Any other questions out there? Nothing coming. We'll sum it up there, but suffice to say that watch this space. This recording will be made available on the hub. We're also sending it to AWI to forward around their network. So welcome to get in touch. We'll make sure we get it to you. So if you know someone that would have liked to be here that can't, make sure you point them in that direction. But it'll be bouncing around on socials from both our project as well as from AWI and others, no doubt. So we'll make sure it's gets around, but it'll be up whenever we get it edited, which won't be too far away, onto the hub. So where you are now, it'll be the recording will be there, so you can forward that around. That'll be great. Really looking forward to hopefully getting a few more breeders involved. Great to have all those that have been, and hopefully we continue to build it and continue to get the work done. Thanks, Amy. Thanks, Gus, for your hard work, and good to see some results tonight. And look forward to them. Where are we at with? We'll be sending out once we get some breeding values generated. We'll be sending out to those participants fairly soon. Is that the plan?
Yeah,
just putting sort of very preliminary breeding values.
Yeah, absolutely. We can definitely send out to participants. In the next little while, so next month, within next month.
Okay. Cool.
Yep. Yeah, what's the best way to do that? I guess to contact Amy.
Through Amy. Yeah. Awesome. Righto. Thanks all. Have a good evening.